To evaluate the integral of a product of secant and tangent, let me write down guidelines. There are two cases. Case 1, when n is even, like 2, 4, 6, 8, then save secant square. Okay, you need to save secant square and change the remaining secant to the even power, because this is even. When we take 2 out, we still have even. Then change that in terms of tangent using the formula secant square x equals 1 plus tangent square. Okay, let me show you an example. If we have, let's say, tangent, any power doesn't matter, tangent to the 5th x and secant 4x dx, since we have secant to the even power, then we save 1 secant square, and now we have secant square remaining. Then change that secant square in terms of tangent using this formula. Let's say I have secant to the 10. In that case, secant square is there. Now we have how many seconds left? 8. So secant 8 x, and this is still tangent 5. We are trying to change this secant in terms of tangent using this formula. The next step, that's tangent to the 5th x. Secant 8th is secant square to the 4th. Secant square to the 4th, and secant square is 1 plus tangent square. So 1 plus tangent square to the 4th. This is secant square to the 4th. Okay, and remaining secant square x dx. Now we make the substitution. U equals tangent, then the differential will be found using find the derivative. That's secant square x dx. Okay, that was the purpose of saving secant square. This becomes du, and the remaining will be a function of u, function of tangent, function of u, and we can easily integrate. Case 2, when the exponent of tangent, the exponent m, is odd. Okay, if m is odd, let me write here case 2. So we are trying to integrate tangent times secant, and if m is odd, then take 1 secant from here, tangent from here, and 1 secant from here. Okay, save secant tangent at the end. Okay, secant times tangent is the derivative of secant, so we are trying to change everything in terms of secant. Save secant tangent, and secant is already good. Now we will have tangent to the even power, right, because 1 secant is taken, so this was odd. Now we have tangent to the even power left, and change that tangent even power in terms of secant using the formula tangent square is secant square minus 1, just the modified. We know 1 plus tangent square is secant square, and we're just modifying, and change tangent in terms of secant using this formula. Let me show you an example. Let's say tangent to the 11x and secant 5x dx. In this case, since the exponent of tangent is odd, we wanna save 1 tangent, 1 secant from here, so we write at the end secant tangent and dx. This will be du part once we make substitution, u equals secant. Out of 10, 1 is there, so we have 10 left. Out of 11, 1 is gone, so we have tangent 10. Now we have secant 5. Now we want to change this tangent in terms of secant using this formula. Okay, so tangent to the 10 is tangent square to the 5th. tangent square to the fifth, and tangent square is secant square minus 1, okay, times secant 5x, and we have secant x tangent x dx. Now next we want to make substitution, u be secant x, then du will be derivative of secant is secant tangent with respect to dx. So secant tangent dx will be du, and this will be a function of secant, which is function of u, and we can easily integrate. Okay, there can be other cases, but there is no clear-cut guideline, so you have to do on the do based on particular question.